Whether you need good help, a genius writer, a brainy tutor, or a data wizard, Intuito for you has them all. It's like having a research dream team on demand.
Hey there, and welcome to The Explainer. So if you're a researcher, you totally know this feeling. You've got this raw, kind of messy FTIR data file, and you need to somehow transform it into a clean, professional-looking graph for a paper or a presentation. Well, today, we're going to show you exactly how to do that. This right here is the big question, isn't it? You've already done the hard part. You ran the experiment, you got the numbers, but how do you make those numbers tell a clear visual story? We're going to walk through the whole process step by step using the awesome software Origin. Okay, before we even think about plotting, we got to take a step back and understand what we're actually working with. This first part is all about the foundation, your FTIR data. Because, if you don't get what the numbers mean, your graph won't mean much either. So, just so we're all on the same page, what is FTIR? It stands for Fourier Transform Infrared Spectroscopy. Basically, it's a super cool technique where you shine infrared light on your sample. Different chemical bonds in your material absorb different amounts of that light, and that creates a unique fingerprint, or spectrum, that lets us figure out what it's made of. And here's the best part. The data itself is actually really simple. Your data file, it's almost always just going to have two columns. Your x-axis is the wave number, which tells you what kind of chemical bonds you're looking at, and the y-axis is absorbance, which tells you how much light that bond soaked up. That's it. Just these two columns are all we need to get started. All right, enough theory. Let's get our hands dirty. We are now officially moving from that data file to our very first plot in Origin. And you're about to see just how fast this part can be. Seriously, it's this easy. Step 1, import your data, usually a simple text or CSV file. Step 2, select those two columns we just talked about. And step 3, you just tell Origin to plot it as a line graph. And boom, just like that, you've got an initial spectrum right there on your screen. But hold on. As soon as that plot pops up, you might notice something weird. Does your x-axis look like it's running from a low number to a high one? Yeah, that happens. It's an incredibly common thing, but don't you worry, the fix is unbelievably simple. Here is the key thing to remember. By scientific convention, an FTIR spectrum always shows the x-axis going from a high wave number down to a low one. So how do we fix it in Origin? You just double-click that axis, head over to the Scale tab, and check one little box that says Reverse. Done. Your graph will instantly flip to the standard, correct orientation. Okay, our graph is now correctly oriented. Now this is where the real fun begins, adding that professional polish. This is the refinement stage, where we're going to take our basic plot and make it look clear, readable, and totally ready for any publication. Think of this as your professional look checklist. First, let's make that line a nice, smooth curve and maybe bump up the thickness a bit. It just makes the peaks pop. Next, and please never forget this, label your axes. Wave numbers, CM-1, and absorbance. So important. Maybe add some light grid lines so it's easier to read. And finally, stick to a standard professional font. These little details, they make a huge difference. A polished graph looks great, sure, but the real story in an FTIR spectrum is hiding in the peaks. Each one of those bumps corresponds to a specific chemical bond doing its thing. So now, let's look at how we can automatically find and label these key data points to really tell that story. Now, the best part is you do not have to squint and hunt for these peaks by hand. Not at all. Origin has a fantastic Find Peaks tool right under the Analysis menu that does it all for you. It'll automatically spot them and label their exact wave number. So it might find a super sharp peak right at, say, 1720, which is that classic sign of a carbonyl bond. Having the software do this for you, it's a total game changer for your report. So at this point, we have a beautiful, perfectly labeled, and scientifically accurate graph. It looks amazing, but it's not much good if it's just stuck inside Origin, right? The final step is to get it out and into the world. Let's go over how to export it correctly so it looks crisp and professional no matter where you put it. And guess what? It's another simple 3-step process. You just navigate to the Export dialog, choose a high-quality format. TIFF is fantastic for printing. PNG is perfect for presentations or web, and then you just have to set the resolution. And for that resolution, there is one number you absolutely need to remember, 300 dpi. That stands for dots per inch, and it is the gold standard for high-quality printing. If you set your export to 300 dpi, I guarantee your graph will look sharp and professional in any journal, on any poster. No blurriness. And just like that, there you have it. We have gone all the way from a basic 2-column data file to a fully customized, totally publication-ready spectrum. And as you saw, once you know the little tricks, it really only takes a few minutes to pull off. So we'll leave you with this question. Now that you have the tools to present your data in a way that's clear, professional, and impactful, what story is your data going to tell? You've already done the hard science. Now you can go tell its story.
And subscribe now for more amazing videos just like that. And don't forget to like, share, and subscribe to yours channel. Thanks for watching.